Nuclear fission is the process where a big atom captures a slow neutron, which makes it unstable, causing it to split apart into two smaller and more stable atoms, with a lot of energy and a couple of neutrons coming out. A fast neutron is harder to be captured by an atom, therefore, they must be slowed down by moderation to increase their probability of capture in a nuclear fission reactor. In this example, the uranium-235 atom is capturing a slow neutron, causing it to turn unstable, and then splitting up into krypton and barium with some neutrons and a lot of energy. Moderation is when a water moderator uses water to slow down neutrons that are traveling at high speeds so that they can be caught by nuclear fission reactors. Large quantities of energy are released during a nuclear fission reaction because when the bigger, more unstable atom splits into two smaller, more stable atoms, the bigger one loses some of its mass. The mass lost gets turned into energy, according to the formula E equals mc squared. The energy that occurs from nuclear fission reactions are from within the bonds of the bigger, more unstable atom. The energy is just released because the bonds are now broken.
Matter disappears during the nuclear reaction. This loss of matter is called the mass defect. The missing matter is converted into energy. You can calculate the amount of energy produced during a nuclear reaction with the equation E equals mc squared. E is the amount of energy produced. M is the missing mass or the mass defect. C is the speed of light. Take a look at the equation. Notice that one neutron was used, but 3 were produced. These 3 neutrons, if they encounter another uranium-235 atom, can initiate other fissions producing even more neutrons. It's the domino effect. In terms of nuclear chemistry, it's a continuing cascade of nuclear fissions called a chain reaction. A chain reaction refers to a process in which neutrons released in fission produce an additional fission in at least one further nucleus. If the reaction will sustain itself, it is said to be critical, and the mass of uranium-235 required to produce the critical condition is said to be a critical mass. A critical chain reaction can be achieved at low concentration if the neutrons from fission are moderated to lower their speed, since the probability for fission with slow neutrons is much greater. A fission chain reaction produces intermediate mass fragments which are highly radioactive and produce further energy by their radioactive decay. Some of them produce neutrons, called delay neutrons, which contribute to the fission chain reaction.
Nuclear fission is the splitting of a heavy element's nucleus to form 2 new elements with smaller nuclei. One of the most important fission reactions is that of uranium-235, which is used in nuclear reactors and atomic weapons. The fission of uranium-235 is initiated when a neutron traveling with enough velocity collides with a uranium-235 nucleus. The collision produces U-236, which immediately splits into 2 lighter elements such as krypton-91 and barium-142. The fission event also releases 3 neutrons and energy. The 3 neutrons are capable of initiating more fission events if they encounter a uranium-235 nucleus. If a sufficient or critical mass of uranium-235 is present, the reaction becomes self-sustaining, resulting in the release of massive amounts of energy in the form of heat, light, and ionizing radiation, an atomic explosion.